Hello guys, welcome to Algorithms Made Easy. Today we will be discussing the question Palindrome Partitioning. In this question we are given a string S and we need to partition in such a way that every substring of this partition is a palindrome. We need to return all the possible palindrome partitioning of S. Some of you might not know that what is a palindrome. A palindrome is a string which reads the same backwards as forward, like ABA. Now, in the first example, we are given a string AAB and here are all the possible palindrome partition of this string. The constraints of this questions are pretty low, that is the length of the string can be up to 16 and the string will contain only lowercase English letters. Now, let's see how we can solve this question. If we have the string AAB, let's work towards how we will find the solution to this problem. We'll first take out the first letter of this string A. And now we need to find all the possible partition of the rest of the string, which is AB. Now again we do the same thing what we did in the previous string, taking out the first letter, checking if it is a palindrome. As it is a palindrome, as single character is always a palindrome, we add that into the list and move ahead. Now the string contains only one letters, that is B, which will be a palindrome. We'll add that value into the current list and this becomes our first result. Now, there will also be a scenario where we can check if the rest of the string AB was a palindrome in itself or not. We check and we find that it is not a palindrome. That means this partitioning won't work. That is, the partitioning A, AB won't work as all the strings are not palindrome. So we backtrack again to the first string and now we take first two values, check if this is a palindrome. It is a palindrome, so we move forward. The rest of the string is now B. As we know, a single character is a palindrome. We add that value into the current list and this becomes our second result, which is AA, B. Now we again take one more character, that is AAB, and this value is not a palindrome, so we do not add that into our result. We see that we have found the two values that were given in the example also, which will be our result or the partitioning of the string which are palindrome. As we can see here, we are going depth-wise in this approach. We will be using DFS in the solution also and we will see how we can solve this optimally. So let's see how we can code this. So we need to do a DFS on the string starting from the 0th index till the very end and add the values into a list at each step if that particular string is a palindrome or not. So we'll have a method DFS which will start from string passing the index 0 and a new list into this. At the end we need to return a result list and we will be creating this list at the class level. Now let's declare this DFS method. So we'll have this DFS method where the first parameter is a string, second is the start value, and lastly a list of string. The first thing that we saw when we are explaining the approach is if we can reach the end of the string and have found all the palindromes, that means this particular partition is a valid partition and we can add that into a result. So it is nothing but if we have reached the length, that is the start is equals to the length of the string, that means that is a valid partition and we can add that into a result. So we will add this value into the result. We will make a new reference of the list and add that into the result and return from here. If that is not the case, we need to take into consideration every value starting from 0 till the end of the string. So we need to iterate from the start till the end of this length. Now we need to check if this substring that is starting from the start index and ending at I gives a palindrome or not. So we will create a method for that with the first value start and ending at I. If this value is a palindrome, then we need to add this string into our current list. So we'll add this into the current list. And now we need to call the method on the rest of the string again, starting from I plus 1 and the list And now when all this depth first for this particular string is done, we will backtrack to the original state, and in order to backtrack we need to remove this value that we have added, and this method is complete. Now we need to apply the isPalindrome method. So I'll have a boolean return type. Now we know what is a palindrome. Palindrome is if it is read forward and backward, it stays the same. So if the start is less than n, and if anywhere we find the value at start not equals to the value at end, that means it is not a palindrome. So we directly return false. Otherwise we need to increment the start, decrement the end, and at the end we return true if we never got any false condition. When we run this code, so we get the right result. Let's submit this. So it got submitted successfully. The time complexity of this algorithm is O of n into 2 raised to power n, because there can be 2 raised to power n nodes in a string of length n, and the space complexity is O of n, as this is the amount of space needed in order to maintain the recursion stack. Thanks for watching the video. See you in the next one.